in example 10, we are told that given the tangent of A is minus 5 over 12 and A is obtuse, that means greater than 90 and less than 180 in the second quadrant rather, then you are expected to find the sec of A. And if we line up these identities like number 1, number 2, and number 3, you can see we should directly go to the number 2, whereby we have 1 plus the tangent square, the tan squared of x. It should give us the sec squared of x. What is the meaning of this? That from 1 plus the tangent squared of A, we should get the sec squared of A. But we are expected to find the sec squared, which means it's already the subject of the formula and we are not supposed to change this line up. So 1 plus, what is the tan squared? Minus 5 over 12 squared. It should give us the sec squared of A. This means 1 plus 25 out of 144, which is basically, if this is over 1, of course, the LCM is 144, which is 144 plus 25, which is 169 all over 144. And this happens to be the sec squared of A. But you can see the question is asking us to give the sec of A. That means the sec of A is the square root of 169 over 144, which is basically 13 plus or minus 13 over 12. But if you look at the question, it is in the second quadrant, because the angle is obtuse. It is already in this quadrant, whereby all science teachers complaining the angle is in this very quadrant. And in this very quadrant, then, this is of course plus or minus, but before we can actually tell the sec of A, we need to verify that it is in the quadrant where sine is supposed, or where cosine is supposed to be negative or positive for that matter. Now, we know that the sec of A is plus or minus 13 over 12. But what is the sec of A? The sec of A is actually 1 over cosine. And you can see the cosine is already negative here. So basically the sec of A is supposed to be negative 13 out of 12. And that is the sec of A, simply because the cosine of A is itself negative in the second quadrant. 1 over any negative number, it remains a negative number. But it is the sign of the part B, whereby we should give the sign of A. Let us talk about the sign of A. It is part B. With the sign of A, we should know that it is very important that we remember. It is very important that we can also remember probably the law number 4, whereby we have the sign of x over the cosine of x is giving us the tangent of x. Is giving us the tangent of x. We can also use that one. And we can use now this row 4 in this one and say the tangent of A is given by the sine of A all over the cosine of A. And we need to make now the sine of A the subject of the formula, meaning that if you cross multiply both sides, the sine of A is going to be the tangent of A multiplied by the cosine of A. It is the cosine of A that we don't know. It is the cosine of A that we really don't know. But basically, if we don't know the cosine of A, but we know the sec of A, cosine of A, or rather from 1 over cosine of A, it should give us the sec of A. That means 1 over the cosine of A should give us the sec of A, which we got to be minus 13 out of 12. So if we cross multiply here, we should get that from here we should get the cosine of A is minus 12 out of 13. And actually it's a reciprocal of this because sec over A is 1 over cosine A. So if we find the reciprocal on both sides, we should have realized that it's the same reciprocal which maintains its negative because our angle is obtuse and only side in that particular quadrant is positive. So it maintains that the cosine of A is negative 12 out of 13. What does that mean? Therefore, if we continue to make sine of A the subject of the formula, it's the tangent of A which is given here, minus 5 out of 12 times minus 12 out of 13, and you realize that at that particular point, we know that 12 and minus 12 cancel out. We still maintain negative 1, but 5 minus 5 times minus 1 is a positive 5, and 1 times 13 is a 13. And it is very true because you can see the sign in this particular quadrant is supposed to be positive. And there you are with our sign of A. All right?